In this video, we'll be learning about the power rule, which is a way to calculate certain derivatives. Recall the derivative of a function at an x value is equal to f prime of x, which is basically the limit as h approaches 0 of the difference quotient. We're going to use this definition to find the derivative of each of the following. Okay, so for part A, we have f of x equals x squared plus x. So using that definition of the derivative, we need to evaluate f of x plus h and then substitute it into this whole limit definition. All right, if I find f of x plus h, just a reminder what that is. That means you're going to take x plus h and plug it in for x. Just like in algebra, when you find f of 2, for instance, you plug 2 in for x. This time we're just plugging x plus h in. And I can simplify that to x squared plus 2xh plus h squared plus x plus h. So I'm going to take all of this and substitute it in here. All right, so let's start putting this together. So the limit as h approaches 0, x squared plus 2xh plus h squared plus x plus h. And then we're going to subtract f of x, our original fraction here. So f of x is whatever our original function is. Distribute your negative there. So minus x squared minus x over h. Any term in the numerator that does not have an h should end up being simplified or canceled out. Okay, let's divide out each term that's left in the numerator by h. So we get 2x plus h plus 1. That 1 is important there as a placeholder. And now let's plug in 0 for h, because that's how we evaluate limits. We do direct substitution. And when I do that, I'm going to get my derivative is 2x plus 1. Okay, so the derivative f prime of x is equal to 2x plus 1. Okay, let's do the same idea for b. This time it's a little trickier because we have x cubed. So when I find f of x plus h, I need to plug x plus h in and cube it, which really looks like this, right? Multiplying it by itself and then by itself again. So let's start by multiplying 2 of them at a time. That gives us x squared plus 2xh plus h squared. And now we'll multiply out that whole trinomial by x plus h. Okay, so you're going to distribute the x squared across x and h, and then repeat that for the other terms. Just one note, I tried to be consistent, and when I had a term that had x and h, I tried to always put x first. All right, when I look at this, I noticed that I can combine like terms a little bit here. So x squared h and 2x squared h can be combined. And 2xh squared and xh squared can be combined. And now I have found f of x plus h. So let's put this in our whole limit definition of the derivative. Subtract f of x, so just subtract x cubed all over h. Any term in the numerator without an h should end up going away, giving you 0 basically when we simplify. And then I'm going to divide each term in the numerator that remains by h. And now I'm going to evaluate and I get that basically the derivative is 3x squared. The 3xh and h squared disappeared once I plugged 0 in. Now it says, do you notice any relationship between the function and its derivative? And we're going to describe the relationship below. So in A, the function was x squared plus x, and the derivative was 2x plus 1. Okay, so let's notice something here. Take a look at this. In B, f of x was x cubed, and the derivative was 3x squared. So what I would suggest you do is at this point, pause the video, see if you can notice any relationship between the function and the derivative. When you think you have an idea, then you can unpause the video and continue watching. All right, some things that I notice here is that when we have f of x equals x squared plus x, and the derivative became 2x plus 1, I noticed that what was in the numerator seems to have dropped down. Okay, excuse me, whatever was in the exponent seemed to drop down. Okay, one thing I notice here, if I look at A, the first term was x squared, and then it became 2x. I noticed that whatever the exponent was seems to have moved to the front. I also noticed that the exponent decreased by 1. Let's see if that works with the x. This is really like x to the first. If I move that down, that would give me 1x. If I subtract 1 from the exponent, I get x to the 0, which is just 1, so that pans out. If I try it with b, same idea. The 3 in the exponent is brought down as the coefficient, and the exponent was subtracted as by 1. So I noticed that the exponent basically is becoming the coefficient, or you could say is multiplied by the existing coefficient, since those existing coefficients were 1. And then the exponent decreases by 1. And if I had to guess then, using that idea, what the derivative of x cubed plus 2x squared plus 4x minus 7 would be, x cubed, we already know the derivative is 3x squared. For 2x squared, move the 2 down, so that's going to give you 2 times 2, or 4. Subtract 1 from the exponent. 4x to the first, move the exponent down, 1 times 4 is 4. Subtract 1 from the exponent, and you have x to the 0, and that's going to be 1, so we don't even need to write x to the 0. And then minus 7, the derivative of that, this is already like negative 7x to the 0. If I bring the 0 down, I'm just going to get 0 there. So my derivative is 3x squared plus 4x plus 4. This basically brings us to the power rule. So if f of x equals ax to the n, then the derivative, f prime of x, is equal to, the coefficient becomes n times a, what the exponent was, times the pre-existing coefficient, x, and we're going to subtract 1 from the exponent. The power rule can be applied to find the derivative of a constant, a single variable, or a polynomial that's formed by adding or subtracting terms. All right, let's take a look at some more examples of this. Once you get the hang of it, you'll be able to go very quickly through it. In number 1, the derivative is simply going to be 7. I can see that I have these imaginary values in here, like this is 7x to the first minus 1x to the 0. Bring your exponents down in front, subtract the exponents by 1. You should know at this point that derivative is basically slope, and think about this line, 7x minus 1, the slope is 7, so it should make sense that the derivative of a line at any point is going to just be 7. Number 2, g prime of x is equal to 6x. Number 3, f prime of x, 3x squared plus 2x minus 1. Basically, anytime you have a constant, the derivative of a constant is equal to 0. Think about if you had the line y equals 4. Isn't it a horizontal line? The slope of any horizontal line is 0. Okay, so that's why that works out. And similarly, that brings us to number 4. The derivative of a constant is simply 0. Number 5, I would get negative 4x plus 9. Number 6 looks a little different here. So it doesn't look like our typical polynomial. We have square root of x plus pi. Anytime you see a radical, I would always try and rewrite it. So we should know that a radical is the same thing as raising a value, in this case x to the 1/2 power. So now I'm going to apply that here. So now I can use power rule. So y prime is 1/2, right? I'm bringing that in front. X. Subtract 1 from the exponent. So notice that gives you negative 1/2. And the derivative of pi is 0. Pi is just a constant. It's just a number. So the derivative of any number is 0. Now I'm just going to clean up my answer here. And when I have a negative exponent, that is the same thing as, if I want to make that positive, it's the same thing as moving it to the denominator. So it would look like this, 1/2 x to the 1/2. And if I clean that up again, that's 1/2 radical x, putting the square root back in. My rule of thumb would be if the problem starts out with a radical, it should end with a radical, and try and mirror those formats. Number 7 also does not look like your typical question, but I can rewrite this using negative exponents as x to the negative 1. And now applying my power rule, I get negative 1 x to the negative 2. If I clean that up, I get negative 1/x squared. Again, since the problem started with a fraction rather than the negative exponent or a positive exponent, I should say, then we're going to put our answer the same way. Number 8, we have a very large polynomial, but we are going to just apply the power rule to each term individually. So 56x to the 6th minus 42x to the 5th plus 30x to the 4th minus 20x to the 3rd plus 12x squared. Number 9, the derivative of x is simply 1. E is another little trick there, just like the pi question before. This is a constant, so the derivative of it is 0. Number 10, I have to rewrite this a little bit before I can apply the power rule. So I am going to multiply these two binomials together. Actually, this is really just f of x. Did not take a derivative yet. So I have x squared plus x minus 6 when I multiply those out. And now I'm going to take the derivative. So now I'll add my derivative notation. So this gives me 2x plus 1. Number 11, I'm going to divide out an x first. And I get x minus 8. And the derivative of x minus 8 would simply be 1. Number 12, I have some rational exponents here. Bring them down. So 5/2 times 2 is going to give me 5x. And we're going to subtract 1 from the exponent. So keep in mind, 5/2 minus 1, you need to get common denominators there. Bring the 3 down here. Bring the 2/3 down times the 3. So minus 2x to the negative 1/3. For 13, I'm going to rewrite that radical first before I take any derivatives. And now I'll use the power rule. So negative 12x squared plus x to the negative 1/2. And since the problem started off with a radical, I'm going to get this back in radical form. So plus 1 over radical x. Notice in that problem, I'm also changing the negative exponent to a positive. All right, for our last question, I'm going to do some rewriting first. So this is really 5x to the negative 2 minus x to the 1/3 power. That's what we have when we have a cube root. Now let's take our derivative. I get negative 10x to the negative 3rd. Keep in mind you're subtracting 1 from the exponent. minus 1/3 x to the negative 2/3. And then let's clean this up so that this matches the formatting of the question. So the question does not have any rational exponents. It also doesn't have any negative exponents. So I'm going to rewrite this as negative 10 over x cubed. Basically, the term with the negative exponent gets bumped to the denominator, and we change the exponent to a positive. Minus 1 over 3. That's dealing with the 1/3 part. And now let's talk about this x to the negative 2/3. I don't want to just make it x to the positive 2/3 in the denominator. I also want to keep the radical format. So this is really the cube root of x squared. Remember that this is the power over the root, and that's how we can put it back in the radical format. Okay, hopefully this video helped you understand the power rule of how to find derivatives of polynomial functions.